we asked to evaluate the integral of e raised to the power 3x exponential 3x sine 5x dx. And I will solve this first and I will prove why the answer is what I'm going to write. I will use a property that integral of anything of this form this, if you notice that this form a is 3 and b is 5, the answer is this. So that's the property I'm going to use. So therefore the integral of e raised to the power 3x sine 5x dx is equal to 3 e raised to the power 3x over 3 squared plus 5 squared 3 sine 5x minus 5 cos 5x plus k. That is this is equal to e raised to the power 3x plus 9 plus 25. 9 plus 25 is 34 of 3 sine 5x minus 5 cos 5x plus k. That's the answer. So anything of this form, that is the integral. So the next thing is now let's prove why this is equal to that. Okay, from our integration by part, if you could remember that integral of u dv is the same as uv minus integral v du. So the major problem, which one is u? Because once one is u, the other one is dv. I gave one thing that it depends on what we are given. So I gave what we call Lipte, where L is for logarithm function. You check if there is logarithm. If it's there, that is u. R is the inverse trig function, while P is polynomial, T is trigonometric, while E is exponential. So now that's the order of u. So you first check logarithm, inverse trig, polynomial. So looking at this, you see that trig is before exponential. So our u is this, and our dv is now e raised to the power as dx. So I'm saying that integral of e ax sine bs dx is now equal to my u is this. So is now u, which is sine bx. I'm using this formula. So if u is that, dv is now e raised to the power as dx. V is now integral of this. Integral of e raised to the power as dx is e raised to the power ax over a minus integral of v, which is e raised to the power ax over a. That's if you integrate this, that's what you get. Du, if you differentiate sine bx, is b cos bx dx. So which is equal to, let's write this first as e ax over a sine bx minus, looking at this, we can bring out the constants, which is 1 over a integral e as. Okay, b is also there, so let's bring out b over a. Do you guess the constant is b over a cos bx dx. So we still integrate by parts. Maybe let's bring it is equal to, so that we save space, is equal to e raised to the power ax over a sine bx minus b over a So we still apply integration by parts here. So my u is that, so which is cos px. Why my, if you integrate this, I still have e raised to power ax over a minus integral of v, which is e raised to power ax over a, and our du, if I differentiate this, is equal to minus b sine bx. That's if you differentiate this, that's what you get, dx. So which is equal to, you open up, we have e raised to power ax sine bx, that's a minus, if you open up this times, that is b e raised to power ax cos bx over a squared plus this times that, there is minus times minus is plus, so this should be minus. This times this is minus already, so this times this is plus, times that is minus, b times b is b squared, so I have minus b squared over a squared integral e raised to power ax sine bx dx. So look at this, because that's where the mathematics comes in. If we continue doing this, we'll waste our time. So what do you notice? We're asked to integrate this, and we still ended here. Do you see? The same thing. So the best way is to make it the subject of formula. So I move this to the other side. Remember that integral of this is now equal to all this. So I'm saying that, okay, we now have this. So we are looking for the integral. So I make it the subject of formula because I'm saying this and this. So if I move this to the other term, I have that integral of e ax sine bx dx. This one comes over to be plus b squared over a squared integral of e raised to as sine bx. Do you get the logic? So I've moved this to the other side, because if we keep on integrating, it won't end. So I will just make it the subject of formula, like x is equal to something that has x, so you collect like them. So I'm collecting like them, so this has moved here to be positive, so we are left with e ax sine bx over a minus b e raised to power ax cos bx over a squared. So what is common? This. So I factor this. So if I factor e raised to power as sine bx dx, so I'm left with 1 plus b squared over a squared. So that's what is common. So if you open up this times this, I have this times that, I have that, is equal to a raised to power ax sine bx over a minus b e ax cos bx over a squared over a squared. So maybe let's, the LCM here is a squared here, so I have a e as sine bx minus b e raised to power ax cos bx. That's our that's the LCM. So why this is equal to, maybe let's just get the LCM. is a squared. So I have a squared plus b squared. So I'm writing this first now. This now times the integral of e raised to power ax sine bx dx. Do you get? This is this. This times that. That's it. So, and if you look at this, what is common is a squared in both. So a squared, a squared. So I have a squared plus b squared integral of e raised to power as sine bx dx is equal to ax sine bx minus ax cos bx. So let's continue. Okay, we now make this the subject of formula. That's what we are looking for. Therefore, integral of ax sine bx dx is now dividing this, so it's now 1 over a squared plus b squared. Do you get? This goes over to be division. As sine bs minus b ax cos bx. So finally, what is common is e raised to power ax, and that is what is here is here. So bringing it out, we have that of a sine bx minus b cos bx. So I've proved that integral of ax sine bs dx is that. So whenever you're asked to integrate this, that's what you use. So that's why I used this very fast. So okay, plus k finally. Yes, plus k. So that's it. So thank you.